Hi, and welcome to the next installment of Excel for Introductory Statistics. In this video, we're going to work through one example, and this is a problem involving correlation and regression. It's actually a two-part question. So in green at the top, we have the question: a real estate agent wants to study the relationship between the size of a house and its selling price. The table below, actually to the left, shows the size in square feet and the selling price in dollars for a sample of houses in a suburban Denver neighborhood. Okay, so it looks like we have 18 houses accounted for on this list, this table on the left. Column A has the square footage, column B has the selling price. And so we have matched pairs. We have two sets of 18 numbers, and they have a natural pairing. First number in column A goes with first number in column B, and so on. Okay, so now for the question. One, use a value of alpha equals 0.05 and the table of critical values to the right to determine if there's a statistical correlation between the size of a house and its selling price. Now, the second question, if there exists a statistical correlation, find the linear regression equation and use it to make an educated prediction of the selling price of a house in this neighborhood that measures 3,500 square feet. All right, so this is the whole point of correlation and regression, is to analyze some data, some things that have already happened, determine if there's a connection there. So is there a connection? You might think, yeah, probably. Bigger houses sell for more. That makes intuitive sense, at least. So let's test that. And then once we've determined that there is a connection, that there is a correlation between these two characteristics of the house, then we could use that to make an educated guess or a prediction about something that hasn't happened yet. Okay, so you'll see on the screen in this large box in the middle these three equations. Now we're absolutely not going to be using these. I just have them on the screen initially so you know what we're going to be using Excel to do for us, rather than using a handheld calculator, which would be so much work. So for example, and I'll get this off of the screen in a moment here, the correlation coefficient, that's that top formula there. Now for this particular example, if we were to plug the numbers into a calculator and just manually crank out this formula, let's see, with 18 pairs of numbers with this many digits, you're probably looking at pressing the buttons on the calculator about 900 times, somewhere between 800 and 900 times you're going to press buttons. This is very time consuming. And then for the regression equation, it's y equals mx plus b, or in statistics we'll say y equals b0 plus b1x. We'll talk about that in a moment. Well, a linear equation has a slope and a y-intercept, and so we have a formula for the slope and a formula for the y-intercept. So you see these three formulas, they're not convenient to use. Right? It's a lot of plugging in numbers and manual calculations. So we're going to get rid of that, and we're going to get rid of this, and we're going to use Excel instead. Okay, so rather than that first formula in the box that I just deleted, the way we calculate the correlation coefficient on Excel is, well, there's a built-in formula. It's equal CORREL. That's the name of the function for correlation coefficient. And in parentheses, we have to tell Excel the location of the data. But in this case, there's two lists of numbers. So we have to tell Excel the location of the x's, and then a comma, and then we tell Excel the location of the y values. So we'll say the location of the y's. Okay, the x's are in column A and the y's are in column B. So what we're going to type in is equal CORREL parentheses. The x values are here in column A. They start at location A2 and they go up to A19. Okay, so that's where the x's are. And then we have to tell Excel where are the y values, where they are sitting in positions B2 down to B19. Okay, and that's what we're typing in. I'm going to put it in this blue box right here for the correlation coefficient. And it's a very quick process calculating the correlation coefficient. And I'm not even going to type manually A2 to A19. I'm just going to use my mouse and select A2 to A19, comma. I'll select B2 to B19. So you see what I have typed into this cell right here, A22, or actually merged A and B22, is what I have written here in blue. And that'll give us the correlation coefficient. Okay, so it's about 0.7. Normally, we round the correlation coefficient to 3 decimal places. So let's round that. We'll decrease the number of decimal places and we'll say, okay, it's about 0.702. Okay, that's not enough to tell us whether or not there is a statistical correlation. Okay, so let me erase this. Actually, I'm gonna need all this room. So let's erase all of this stuff. Okay, so the correlation coefficient, it's always going to end up being a number somewhere between -1 and 1. We've got 0 right here in the middle. Now, when the correlation coefficient is close to 1 or close to -1, I'm going to highlight that part of this little number line green. When the correlation coefficient, this number we just calculated, is close to 1 or close to -1, the answer is yes. Remember, this is a yes-no question. Is there a statistical correlation? Is there a relationship, yes or no? Well, this is how we figure out whether it's a yes or a no. If the correlation coefficient is close enough to 1 or close enough to -1, the answer is yes. And if the correlation is too far away, I'll highlight this red. Okay, red for no. We'll say this is the no region. Okay, so wherever the correlation coefficient falls, if it's the green region on the right, that's a yes, that's a positive correlation. And the green region on the left, that's a yes, it's still a negative correlation. And in the middle, it's red. So that would be no, not a statistical correlation. Now, how do we know where this threshold is, this cutoff between when the no becomes a yes or a yes becomes a no? Well, those are the critical values. Those are the critical values. So you'll see in the problem, it says use alpha, that's the significance of the hypothesis test, which we'll talk more in detail about later in another video. This video is a very basic introduction to, this is sort of the process of hypothesis testing without actually calling it that. So alpha equals 0.05 corresponds to the middle column in this list of critical values. So let me highlight that. We're using the middle column, so let's highlight this yellow. If the direction said use alpha equals 0.01, we would use the column on the right and ignore the middle column. But for right now, we are ignoring the alpha equals 0.01 because the directions say use the 0.05 column. Okay, so now which one of those is our critical value? Well, the first column is n. Now n is the number of pairs of data, not the number of individual numbers. We have 18 pairs. There's 36 numbers, but there's 18 pairs of numbers. So we'll go down to the Yeah, let's switch it to blue, and blue and yellow should make green. So we have 18 for our size. We're using the middle column, and so there in green, you'll see that is our critical value. And actually two of them, we use the plus and the minus. So for this problem, it's just for this problem, just for a sample size of 18 pairs, the critical values are plus or minus 0.468. So let's put a 0.468 and a negative 0.468. Those are the critical values, and that is how you find them. You need two things. You need alpha, and you need n, and then those two things on this chart are what you allow you to determine the critical values. I'm saying values plural because it's always a plus and a minus. All right, and now we've got that first question done. We say, well, okay, well, our correlation coefficient, that is the 0.702, and that falls to the right of 0.468, somewhere in that region. So it's somewhere in the yes region on the right. So the first answer is yes, there is a statistical correlation. Now, once we have that, then we can move on to the next step. Find the linear regression equation. Now to do that, we're going to do it a little bit differently. There's not a built-in Excel function for finding the slope and the y-intercept. We're actually going to graph the data and use the graph to very quickly find the slope and the y-intercept. I'm going to show you how to do that right now. It's very quick. Graphing on Excel is very, very easy. You highlight the numbers that you want to graph. Now we've discussed in class already that the graph of a set of matched paired data is called a scatter plot. So we want to construct a scatter plot. So we highlight the data, go to the insert ribbon, and click on the little icon that looks like the graph, the type of graph you want, and that looks like this one right here. It's just a scattering of points. And there we go. There is our scatter plot. Perfect. Now we don't need to do any edits or add any detail because we're not, the purpose here is not the graph. The purpose here is the thing that comes after the graph, and that's the equation of the regression line. So to add a regression line, you first need the scatter plot. Now I'm going to click on any of the points. It doesn't matter which one, but I'm going to click on one, and now they're all selected. And then I'm going to right click and go to Add Trend Line. Trend line. In statistics, we say regression equation. In Excel, the term is trend line, but they are the same thing. Trend line is the Excel term for regression equation. So we want to add one. We want to add a trend line. Now, there's a lot of different types. Linear is the one we want, and that's the one that's default selected. So you want to make sure linear is selected. And what we want is the equation, right? The directions say find the linear regression equation. So to get the equation, all we have to do is click on this box that says display equation on chart. Display equation on chart. It's going to be small and in an inconvenient place, but that's fine. We could just move it somewhere nice, and we could even make it a little easier to see. All right, so let's do that one more time quickly. Scatter plot, so highlight the data, insert, a scatter plot. Highlight the data on the graph, right click, add trend line. Make sure it's linear. It should automatically be default selected to linear, but if it's not, make sure it's linear. And then click on the box that says display equation on chart. And you're most likely going to have to move it and increase the font size if you like. All right, so y equals mx plus b. There's the slope, 72.992, and there's the y-intercept, 214,434. So our regression equation, in algebra we say y equals mx plus b. In statistics, we mean the same thing, but generally you'll see the notation b0 plus b1 times x. It doesn't matter what the order of terms is, the coefficient or the number connected to the x is the slope, regardless if it's first or second. The number connected to the x is the slope. So the slope in this case is 72.992. I'm going to type that in over here in the yellow cell all the way on the bottom left-hand corner. So b1. I'm just going to manually type in the 72.992 and the y-intercept. Oop, I don't want that to be a dollar amount or a currency, so that's easy to fix. Let's go to the home ribbon, drop down. You see it's selected as currency because everything above it's a currency. Let's change it to just general, 72.992. And the y-intercept, we have 214,434. And that's actually fine to leave as a dollar amount because it is dollars. All right, now for the last part of the problem, the prediction. So we've already said yes. There is a statistical correlation because the correlation coefficient was in that region above the critical value. So now we can make a prediction. Ooh, how did that get highlighted? So now we can make a prediction. So what that basically means is we're given an x value. It's up here, in the last part of the question. Find a linear regression equation and use it to make an educated prediction of the selling price. So find the selling price. That's the y value. So find the y value of a house that measures 3,500 square feet. So we're given. So basically what this comes down to is x equals 3,500. What is y? All right, so that's the question. All right, so we could replace the x with the 3,500. We could take that 3,500 and pop it in where we see an x. So y equals b0 plus b1 times x, and we've got all that over here. So let me type in the square footage, which is going to be 3,500. Let me zoom in a little bit down here. So B0 we have, that's the 214,434 plus B1 times X. So that's 72.992 times 3,500. We could use parentheses just to make it look a little better. And then that's the process. We use the data to make the model, the equation. That equation has an x and a y. Generally, we're given the value of one of those variables to plug in to find the value of the other. Now, I'm not going to do it manually again. I'm going to use Excel for this. So let's say equal B0. I'm just going to click on the numbers. I'm not going to type them in. I'm just going to click on the locations. So that's the value of the y-intercepts plus B1, which is the slope, multiplied by the x value. So I've got B25, B24, and B27. That's just the locations of these three numbers. And voila. I'm going to change to a different font color, but what we're predicting is that if the house measures 3,500 square feet, then the selling price should be $469,906.00. You know, think about it. If you're going to sell a house and you have a real estate agent do the work for you and list it and sell it, you know, you want to know that that person, that real estate agent is not just pulling numbers out of thin air and, you know, making numbers up. You know, the listing price and the sale prices that you would want to consider accepting should be based on some, you know, previous data. They call it comps, comparisons. Like in the real estate lingo, they call them comps. So you may or may not have heard that term before. Okay, so that about does it for this one. Correlation and regression. You know, a lot of steps here. This wasn't just one problem. There was the correlation part of the problem. Then there was the find the regression equation part of the problem, and then there was the use the regression equation to make the prediction part. So it was really three parts of the problem. Okay, so that does it for this video. There's going to be a couple more videos in which I go through similar problems, not the exact same type, but very similar problems. Okay, that is it for now.